Statistics, week 2. So last week we were just learning about some of the basics in statistics, that we take samples from a population. We do that to try and analyze things about the population. Like say we're talking about humans. Is there a problem with obesity in a certain region? Well, we would have to take some data and figure that out. You might say, well, let's just go check everybody. I live in a small town and I don't think I could find a list of everybody that lives in the town. People come and go regularly. It's not an easy thing. Maybe I'm talking about fish though, and I'm concerned about toxins in fish. Can I easily get every fish in a lake? Answer is no, I can't. Maybe I manufacture nuts and bolts and I want to know, is the bolt the right size and weight on average, right? I can't check every single bolt easily. I have past bolts, current bolts, future bolts. Not an easy problem. When we take a sample, the sample is made up of cases. Those cases have variables. A case is something like a person, and I measure their age, their weight, their height, a bunch of other things. Could be a bolt, where I measure the bolt's length, I measure the bolt's weight, I measure the thread count, I measure the thread direction. It could be a fish, I measure things about the fish. So a case is the multiple things that we have different variables on. And again, a variable is some common category for an object like a human or a fish or a bolt. Those variables are either categorical, like I'm trying to figure out is the fish male or female or neither, or am I measuring something like the weight, quantitative. So last week we looked at what's a sample, comes from a population, we have cases and variables from a sample. Variables are categorical or quantitative, and then we looked at analyzing a categorical variable. So let's look at a sample, try and figure out the population, and then look at a couple different variables. So a little review from last week and then what's going on this week. So some useful things. I'm taking a look back at week 1, excuse me, and looking into week 2 here. Under general stuff, useful websites. I'm going to play around with Google Drive and Google Sheets today. StatKey is a website that goes along with our textbook. And all of the data that's listed in our textbook, you can also find by going to the title here, Data Sets, and I'm using the 3rd edition. You can grab them as an Excel file. I have them as what are called CSV files, and I'll show you those in just a second. At the very bottom here is a description of what the heck's in there. So I have that document up here. There's a table of contents at the beginning. So if you know you have a particular data set and you want to know more about it, this is a big document. You just go in here, you find the data set you're looking for. I'm looking for the one called nutrition, so I'm just going to search for nutrition. And I want, yes, nutrition study is on page 65. And so here I can read a little bit more about the 315 individuals. So those are my cases, and then I have 17 variables, and then they give me a little bit more detail. So I'd have to read the detail to figure out what population this is pulled from. So let's see, cross-sectional study, investigate a relationship between person's characteristics, dietary factors, plasma concentrations, blah, blah, blah. Study subjects were patients who had an elective surgical procedure during a 3-year period to biopsy or remove a lesion from a lung, colon, breast, skin, ovary, uterus. All right, so not everybody gets this done. So I can't say this is all adults in the US. I can say, well, these are adults who have an elective procedure of this type. So really, the population is described in that sentence right there. So if I was writing this up for a homework assignment, I would just put that in my own words, being sure to say, hey, they had an elective procedure related to these organs here. Okay, so that's the population. The sample is the 315 individuals, then I got a whole bunch of variables. So let's say we were given a link to one of those. Maybe the whole drive here. I want the nutrition study. When you first open one of these up, it's going to appear as a CSV file, which kind of looks like a spreadsheet, and it kind of is, but not really, because a spreadsheet has all these things you can calculate. So the next thing I would have to do is, once I'm logged into Google with this CSV file, I would then have to open it in Google Sheets. Now it's an honest spreadsheet where I can run calculations on it. When you do calculations on a sample sheet like this, it's always a good idea to take whatever you're analyzing into a different tab and leave the original data alone so you don't screw anything up accidentally. So I'm going to take a look at the categorical variable smoke. And according to the description back here, smoke is coded as no or yes. So smoker, question mark, are you a smoker? Right? So they could have put that in a better sentence for me. Pretty sure they asked somebody, hey, are you a smoker? And the person answered yes or no. Didn't answer like used to smoke 30 years ago or I just quit last week. It's a little sketchy, but we're going to go with it. Okay, so either they're a smoker or not. Things aren't always that simple. So I want that data. Usually when I grab a specific variable, I grab the identifier to go with it. Help me keep track of stuff. Less likely I'll make mistakes. So I'm going to copy that column into a new tab at the bottom here. Spreadsheet tip: to copy a column, Control-C on the keyboard. If you're a Mac user, it's Command-C. And then to paste, it's Command-C on a regular computer, non-Apple, and Command-V. Oops, I messed that up. Got my C's and V's and controls and commands. Copy and paste. Control V. There we go. Now, to summarize this, I want to know how many no's there were, what proportion there were of the no's, and then what proportion of yeses. And it turns out it's not too hard, but it's not too easy either. So I'm going to make a summary table here. And in that summary table, I need to count the yeses and the nos. Let's count the nos first because they come first in alphabetical order. Oops, I want that down here. No, so this is the value I'm counting of the variable. And then I also want the proportion. Proportion. And I also want to count the yeses. To count, there is, if you go equals count, it says counts numerical. Well, no is not a number, right? So I have to count words. To count words, you use count if. So I do count if. Range means where you're looking to count stuff. And then here, it's got to be quote to say a word is coming next. I want to count every time it sees the word no in that column. Close parentheses, 272. Do the same thing for the yeses. Equals count if. And then I go, hey, look in that column, please, comma, quote. Anywhere you see a yes, count it. And I wonder, is this case sensitive? YES? It is not case sensitive. Okay, good to know. Sometimes these things are, sometimes they're not. All right, so there's all the no's and the yeses. And the only way to count if there's a yes or a no is basically to count the no's and then count the yeses and then just add them up. So as far as my total goes, let's do that version of total. It's better. I'm just going to, mess that up. Total. I'm just going to add the two numbers above. Best way to add stuff in a spreadsheet is the sum formula, and then use your mouse to highlight or your touchpad, whatever, what you want to add up. Okay, it says there's 315 total. So now to get the proportion, I take how many times we found no divided by the number of cases. So equals, let's take that number, divide by the total. And then for this one, equals, anytime you do a calculation, you got to go equals, that whatever's in that cell divided by whatever's in this cell. And you don't want to retype numbers if they're already on the screen, otherwise you might make a mistake. And if I add those proportions up, so if I do the sum on that, it should add up to 100%. 100% as a regular number is 1. When we do proportions, we either state them as a fraction, a decimal, or a percent. The computer automatically states them as a decimal. You can convert if you want. So proportion could be either stated that way. If you wanted to see a fraction in a spreadsheet, that's kind of a pain in the butt. You have to type a little apostrophe first, and then you can grab this. Oh, no, it's not going to let me do that. I guess I'm going to have to just retype them. 272. Yeah, fractions in a spreadsheet are kind of a pain in the butt. So I usually don't do that, but that is one way we might state the answer. Spreadsheets work better with whole numbers and decimals. But I could state it as a percent. So maybe I want to put that right next to it by just saying, hey, replace that value over there. I can automatically fill those over here. And then for this column, I'm going to say, hey, give me a percent. Oops, percent. There we go. Percent usually gives 2 decimal places. As far as rounding goes, when I'm using proportions, I usually do like 3 or 4 decimal places unless I have a good reason to do otherwise. So I'm just going to shrink these guys down to 4 decimal places just for the heck of it. So summary statistic for a categorical variable is to count them up. Now the count's kind of meaningless without the total. So generally the proportion is the big idea here. So I'm going to highlight that. That is the main summary statistic for a categorical variable, and we're going to look at that a lot throughout this quarter, and it's just how many of what you're looking for divided by the total. All right, so let's label this. This is a little review of last week. This was smoke, question mark. Now, if we look back at the study, ID. ID is an identifier. It's not really a variable. Although it does vary, it's somebody got to randomly assign the number 1, and somebody else get to randomly be number 2. It's just like my parents happen to call me Gary. These people happen to be named 1, 2, 3, and 4. So this is a non-variable here, but it's an identifier. So somewhere else we could go back to whoever wrote this study and say, hey, can you give me more information about person number 3 if you have it? And maybe they have more information, but they're not going to give me their name. All right, but we know person number 3 was 38. They didn't smoke. Their quetelet was 20. Vitamin was 2. What is 2 for vitamin? Let's go look. Vitamin is a code 1, 2, or 3 for regularly, occasionally, or no, I don't really take vitamins. Okay, so although it looks like a numerical variable, a quantitative variable, it ain't. It's a categorical variable because people got put into 1 or 3 categories. They regularly use vitamins, they occasionally use vitamins, or they don't use vitamins. Good to know. Averaging those numbers would be worthless. Okay. Could I do a proportion on those? The answer is yeah. I could count all the ones and divide by how many people there are, and then I could get the proportion of people who use vitamins regularly. All right. So I want to look at, let's say, calories, number of calories consumed per day. And sometimes when I copy over things like this into a new sheet to analyze, I'll usually put a little more information. Let's make a new tab. Double click down here. We'll call the tab calories. And then I'm going to put the identifier in column A. So let's put this in column B. And I would rather say the calories per day, because that can get confusing if you don't have the, and that's not too much longer for a variable name. All right, and let's put the identifier in there. Now, chances are everybody has a slightly different number of calories per day. Maybe 2 people had the same exact, but I don't think so. We could sort it to check. When I sort data like this, usually what I do is I highlight all relevant columns and then go to data and go down to the one that's just called sort range. Then we can be very specific and make sure that we get things right. So I go to sort range after I highlight everything. I say, yeah, there's a header row and it's already sorted by ID. I want to sort by calories per day. And so then it'll put them in order, A to Z is smallest to largest. So I can see there's some people that had, oh my gosh, 445 calories per day. That is like, I think my cat eats more than that. That's frightening. And then if we scroll down, there were like 315 people in this list. Whoa, 6,662 calories per day. Wow, that's like Thanksgiving Day twice in a row. That's a lot of calories. All right, so here we have them in order, and you can kind of surf through there, and I don't see any 2 that match in order here. Chances are everyone's different. They could be some that's the same in some data sets, but not this one at the moment. But that doesn't really matter. What matters here? These are numbers, they're measurements. It's not like a yes or a no, or a male or a female, or a smoke or don't smoke. So using a proportion on this set of data isn't all that meaningful unless you're doing something specific, like you saying, hey, a cutoff of 1,000 calories, under that is dangerously low. We might want to say, hey, what's the proportion of people who have under 1,000? Right? So I could use a proportion on a quantitative variable, but usually we do things like, what's the average number of calories these people take in, or what's the maximum or the minimum or the median? So common summary statistics that we use for a quantitative variable are average. That's a measure of the middle. Sometimes we call that the mean. So let's throw that in here. Mean. That's, again, the middle I mentioned. Standard deviation is a measure of spread. Standard deviation. Usually I abbreviate that STD, sometimes just S. And then often we'll find the minimum number in a group. We'll find the median number in a group. And we'll find the maximum. And then there's some other special percentiles and quartiles we'll talk about later. So I'm going to find these summary statistics. Mean on a spreadsheet is average. So I just type the average command. I want the first one. And I just grab the column. It'll ignore the text. So the average is 1,796.65-ish calories per day for this group of 315 people, with an average spread, and this is spread from the middle, STD, always STDEV.S means it's a sample. The other ones work a little different and they'll give us a different number. So I always want the STDEV.S. You'll learn more about that in a couple sections. And then min's pretty straightforward. Min, oops, got to type equals for a calculation. Grab the min of the data. Median is the middle number when they're in order, and we always tell the computer to pick that for us because there's not always a middle number. There's like two numbers in the middle and we average them. Equals median, if I could type. And what is it doing? The median, it's guessing at the wrong numbers. Don't let the computer do things for you if it does them wrong. And then max equals max data. So those are some of the common summary statistics. You'll see a few more later: quartiles, interquartile range, coefficient of variation, and a few other fun ones. I want to focus on the average and standard deviation. Let's colorize those. And I want to compare the mean and the median. So I'm going to actually give those a different color. Let's make those light greenish. Cool. All right. Often we make a chart or a graph of the data because a lot of people just don't like looking at numbers like that. So usually I'll graph those instead for my audience. And section 2.1 looked at some bar charts for those. To make a bar chart for quantitative data, we do what's called a histogram. And I'll explain a histogram here, hopefully. So we want to highlight the data and then say insert a chart with the insert chart button. Computer says, let's make a line chart. That's totally worthless. Worthless. Let me repeat, worthless. So that was a bad suggestion. Each of these are crappy suggestions. The only meaningful chart you can make from raw categorical data is a histogram. What does a histogram do? Well, Google automatically made groupings at the bottom here. And let's see, let's blow this up a little bit. And I can't get much bigger without. All right. It went from 0 to 411, 411 to 823, 823 to 1,235. And what it did is in between these two numbers, it looked at the list and counted, okay, how many were in that region? How many people were in this region? And so on. These are kind of weird numbers. Google picked them. They had a good reason. They have a computer program in the background that says, ooh, I like this number. But we humans can say, you know, 400 or 500 would be a nicer separation there. So I'm just going to go customize my histogram. And instead of having Google automatically pick these numbers down there, and these are equally spaced, by the way. If you look at the difference between them, you find they're all pretty close to 411.76 apart. I'm going to pick a nicer number like 400. So then it goes, is there anybody from 0 to 400? Doesn't look like it. 400 to 800, there were some. And if I click on it, actually I got to get out of the settings there. If I click on it or point to it, there we go. It'll say there's 7 in that column. And then from 800 to 1200, there were 43. 87 in this category, 1200 to 1600. And we can see that most people had from 800 to about 2400 calories per day. Majority of the people fit in here. There's a few people that consumed over 3,000, not many, 1, 2, and there's, I guess, a couple in here too, 6. So there's maybe 6, 7, 8, 9, 10 of them out of 315 that consume more than 3,000 categories. And then there's this one crazy individual who consumed over 6,400 calories. Now, every histogram is based on your starting point and the distance between these categories that we count. And you can always make your histogram a little different by choosing a different starting point and choosing a different width. So to do that here, I go back to Edit Chart, Customize the Histogram, and instead of 400, I could choose 500. And the computer automatically starts at 0. Maybe I wanted to start higher because I know, for example, that the lowest one is 445. So I could go down to the horizontal axis here and say, let's start with a minimum of 400. It's got to be a little under that minimum there. And then it goes 400 and 900. That's kind of weird. So maybe I want to do something different for the histogram. And instead of scaling by 500, I could try the 400 again. 400, 800, 1200. So what's the best histogram? The answer is there isn't one. You just have to make a choice and just stick with it. So the starting at 400, that looks a little weird to me. So I'm going to go back to start at 0. So horizontal axis, I can just delete this. And then series, I think I like the 500. Oops, not series, histogram. So you have to decide on what's a good histogram. And generally, don't stick with the one the computer calculated right away, because those are just weird looking numbers, and that's just going to freak your audience out. Like, why did they pick those numbers? What's special about 411.76? I don't know. There must be something special. They picked it. There wasn't anything special. It's just a computer algorithm. All right, so I just want to draw on this a little bit, and I want to use some other data. So let me screenshot this into my notebook. Back, there we go. And I want to show you why the mean is different from the median in this case. And I also want these summary statistics. Oops, where'd my screenshotter go? There it is. So let's throw those in there too. Oh, my cat's thinking about attacking me. Wish me luck here. All right, so magic whiteboard, what can you do for us? So notice this data has kind of a tail over here to the right. So if I were to try and draw a line smoothing this out, hi kitty, please go away, don't step on my computer. It's a bad time. She's hot. It's like 112 outside, hey hon. All right, so this has a right tail when I look at the graph. The tail is the skew, so we would also say this is called right skewed. So this has a right skew. Generally, when you have a right skew, the numbers out here are unusually large compared to the rest. They're on the right, right is larger, right? So the numbers in here are unusually large compared to the others. Unusually large compared to everyone else, right? They're way the heck out there. Even these guys here are kind of unusually large. That's a bit of a tail right there. When you have this is quite a large skew to the right, what's going to happen is those big numbers are going to make the mean higher than the median. Because the median, it just wants the middle number. It doesn't care whether that max is here or here or here. It doesn't care. It just says, hey, I'm right here, I'm in the middle. But the mean, you have to add up all the numbers and divide by how many, which means that big number is pulling the mean to the right. So what's that like? That's almost 1800. So my mean is right about here. And the mean is called x with a bar over it. Mean. Then we've got the median, which is about 1,600, almost 1,700. So that is just over this way a little bit more. So that over there next to it is the median. Median is usually given the letter M for median. And when you have unusually large data, you have a right tail, those bigger numbers pull the mean away from the median. Again, the median doesn't care who the biggest number is, all it knows is it's in the middle. Median, however, the biggest number is used in the calculation, it matters. So a little bit about data and histograms. When we talk about the distribution of data, we're talking about the shape of a histogram, and that's what you're going to be learning about this week. That shape is related to the mean, the median, the standard deviation, and all of the other numbers, which we summarize with only a few numbers. So we're going to get used to this descriptive summary of statistics, this graph called a histogram, and then we're going to use this stuff to make predictions about populations later in the course. So I hope this was helpful. A little overview and review. Have a good day. Do good math. Bye-bye.